So the next talk is CP steering, CDN, and protocol-aware content steering solution for HTTP adaptive video streaming. And please introduce yourself.
Hello, everyone. I'm Sindhu Chelappa, a PhD student from the University of New Hampshire. I'm here on behalf of the authors of the paper, Reza Farahini and team, who worked on the CP steering, which basically steers between the clients on behalf of by taking CDN and the protocols into the aspect. So this is a brief agenda. We'll just look into the introduction aspect and then the motivation for this work and the workflow. We all know that in the HTTP server, all the video is being encoded at different video formats, and depending upon the network condition and the current playback condition, the client would be able to adaptively select the bitrate for the playback. But underneath, if we look into the transport protocol, there is lots going there. In the transport protocol, if the transport protocol, transmission control protocol, which is TCP, has its own congestion control, and TCP is a reliable and a connection-oriented protocol. To make this data in the TCP, because the data in the TCP goes as a single stream of bytes, which is a clear text. To encrypt the data, we need the TLS, which is in the security layer, and then we have on the application layer, in the initial stage, we had HTTP1. But if we load a web page with HTTP1, there can be like 6 TCP connections can be opened with HTTP1, but that resulted in the head-of-line blocking or in HTTP layer, because if one HTTP request is being blocked, and then the remaining HTTP request will be blocked one after the other, so which resulted in the head-of-line blocking of HTTP layer. So that led to HTTP2. So HTTP2 has stream multiplexing. What we mean by that, within a TCP connection, there are multiple parallel HTTP connection to transport the request that goes over. So under HTTP2, what happens is, in the data that goes over the TCP layer is not aware in the HTTP, so which results in the head-of-line blocking in the TCP layer. So that led to the protocol QUIC. So QUIC operates on an unreliable UDP. Even though if it operates on the unreliable UDP, QUIC is a reliable protocol, it is connection-oriented, it has its own congestion control, and also the TLS 1.3 is integrated within the transport layer of QUIC, and also one QUIC layer will have multiple independent streams within the QUIC connection. So when the underlying transport protocol varies, there is a need for changing the application protocol, which led to HTTP3 because of a different header compression, and also it has its own prioritization schemes. So now we will look into the content steering approach that was recently proposed in Dash. So in a Dash content provider, first it would be able to send the MPD files. The content provider uploads the MPD file to the different CDNs that are present. And also, it uploads the segment to the CDN. Then the Dash content provider sends the update for the steering information to the content steering server. After the updates of the steering information are obtained by the content steering server, and then the Dash client, when it requests for the manifest to the CDN, it also sends the request to the content steering provider. And depending upon the response from the steering server, the Dash client would be able to steer between the different CDNs that are present. So depending upon if one CDN fails, the Dash client would have the ability to steer between the CDNs. So the authors are motivated by this approach, and then they propose, like, how do we augment the current content steering solution with the multi-protocol stack? For example, when there are TCP and QUIC in the transport layer, how can this be used under different network condition, like a lossy network condition or a stable network condition, in an acceptable quality of experience and latency? So that led to CP steering. If we look into the workflow of the CP steering, the content provider uploads the manifest with the base URL of the CDN, and also the base transmission protocol to the different CDNs and the content steering. So after the manifests are being uploaded, the segments are uploaded to the CDN, and it is to be noted that here, CDN 1 here supports only TCP, and CDN 2 supports QUIC protocol. So after the segments are being uploaded, the steering information is provided from the content provider to the steering provider, and when the client requests the manifest, it also requests the steering information from the steering provider. So once the steering information is given from the steering provider, in this case, let's say that if the steering provider selects CDN2 along with the QUIC protocol, and now the client selects the request, sends the request for all these segments to CDN2 with the QUIC protocol, and then the segment transfer happens on. But if there is an update with the steering information from the content provider, and then the client is also requesting the steering information, it gets the updated steering information, and now if the steering provider decides that if the CDN1 and TCP work better, then now the client has the ability to steer between the steering content delivery network along with the transport protocol. Now, how does this work in different heterogeneous environment? So now, there are 3 content delivery network, among which CDN1 supports QUIC and TCP, CDN2 supports only TCP, and CDN3 supports QUIC. And there are different clients which have their flavors. So now the client 1 supports TCP QUIC, client 2 supports only TCP, and here HTTP means it's HTTP 1 or HTTP 2 over TCP, and QUIC means it is HTTP 3 over QUIC. And the last client supports QUIC. So now, after the manifest is being uploaded to the CDNs, and let's say that the HAS steering provider got all the information about the steering details from the content provider, now the client requests the steering information from the steering provider, and then it has like different paths to walk over. So with these different combinations of the protocol and the steering solution, the 3 clients almost have 4 possible solutions to steer between the content delivery network. So let's say that if client 1 wants to go over TCP, it can choose either CDN 1 or CDN2. Likewise, if it wants to go over QUIC, the possible options are between CDN1 QUIC and CDN3 QUIC. Likewise, in a heterogeneous net environment, the steering provider would be able to provide multiple options to that. So to conclude, the authors have proposed a content steering solution in a multi-protocol and a multi-CDN environment. And in the future, they plan to integrate the CP steering strategy with Dash.js and to evaluate the performance in real-world testbed scenarios. Thank you all for your attention.
Question, please? Somebody raise hand? Nobody? Okay.
Good morning. Thanks for your presentation. My questions are related to the communications between the clients and the steering server. Is that an explicit API call? Are the steering instructions inferred from the manifest? Are like the steering directions inferred from the URL that the customer's request is sending to the steering server? How does that communication layer work?
You mean the communication between the client and the steering server?
Yeah.
Basically, the steering server is going to be an intermediate between the CDN and the client. So I believe that it would be over the URL like you mentioned.
Okay. So if your example on the final slide where I have 3 customers supporting different protocols, the steering server would know which protocol the customer or the client is supporting based on the URL that the customer's requesting, or is it in like the body of the manifest? How is the client's capabilities inferred?
You mean, can you repeat the question again?
Oh yeah. Mm-hmm. How are the client's capabilities inferred by the steering server.
Oh, inferred by this. Okay, so initially the content delivery network has all the information about the client, because once you give the information about once the request comes, even for Quick we have an header which is known as alternate source, which is the alternate source header, which means that it is going to support Quick protocol. So just by the HTTP request and response, they will be able to aware of which protocol is going ahead.
That absolutely makes sense. Thank you very much.
Welcome.
Hi, yeah, I have a question about how the system interacts with existing HTTP2 and HTTP3 discovery, which works today using usually alt service or HTTPS records, and also availability of Quick using, a lot of times browser implementations will race Quick and TCP connections. So can you talk about those interactions?
Are you asking about the server side?
From the client side, like if the client gets information that it should use Quick, when it talks to a particular CDN, that may, I don't know, maybe the CDN has had to temporarily disable Quick, or the client is on a network where UDP is blocked or UDP is slow. A lot of times clients will race Quick and TCP.
Okay. So let's say that if the client first requests a CDN and it gets the manifest file, and afterwards the client is going to contact the steering server. So the steering server is going to give the information about the CDN, which protocol it is using, along with the steering information about the CDN. So along with the CDNs, it is going to provide the protocol that is supported as well. So by that, the client will be aware of the CDN's underlying protocol.
Okay, thank you.
You're welcome.
More questions? We still have 2 minutes. Okay.
Yeah, thanks for the presentation. Did you consider like comparing this to say if you would include the information in the manifest itself? Say you have a list of CDNs, so you would say go to Dash, propose to include like information about the protocols that each CDN option offers, and then the client would still be in control. Did you have a chance to compare that to what you're proposing here?
You mean like to compare with the manifest?
The information that the steering server would give, could you embed that in the manifest in the first place and then have the client?
I think we are
Choose.
planning to do that.
Okay.
Do that in the future.
Thanks.
Yeah.
Okay. So in case there is no more questions, so let's thank the speaker.